So, yeah. Okay, so yeah. Some Vietnamese, but I don't need to use English. Okay, now we just pick up Latin law. Latin law, right? So we have a voltage equation. This is V phase. V phase is EA minus J XSIA minus IA I. Right? Yes. Like this one. So if here is x-axis, here is y-axis, right? That means this one is xy coordinate, right? Now I don't want to use xy. I use dq coordinate. What does this mean? dq. D means directive and Q means qualitative. So that means this is the axis, directive axis, and this is qualitative axis. Okay. Yeah. D and Q. So any vector here, we can analyze to become two components, right? For example, if we have EA, that means we have EDA. Okay? Yeah. Plus EQI. Right? We find projection of EA into the axis, we find projection of EA into Q axis. D means directive. And Q means qualitative. Okay, so if I would like to ignore the vector, we can get EDA plus J EDA plus EJEQA. Do you read me? It is real part. This is imaginary part. Or if you keep the vectors like this. Okay, now we come back. Here, we analyze this equation into the axis component and Q axis component. You can guess. You can get. Okay, you can get. Now we have V phase. V phase in the same direction with D. Right? Still design. Go. V phase is in the same direction with D. Okay, so we just say V phase. So EA. So EA we have EDA. I just pick up for D. So for EDA plus JEQA. Okay. Yeah. Minus J's X F D plus J's XSQ times IA. IA we have IDA plus JIQA. Okay, yeah. And then it's minus IDA plus JIQA times RA. I is equations. So we get this one. Okay. U overdose mean we face. You know? Some Vietnamese textbooks they use it. U. Okay. So continue. So here I guess it's we face overdose. Maybe here we keep EA. We don't need to convert the S's into S's. Here EA. Okay. So minus. D and D, right? D and D. So you get what? J's, X, F, D, I, D, A. Okay. D and Q, 0. Okay. Because 90 degrees, so when we take dot products, cosine 90 degrees, 0. Okay. Yeah. So minus J's X S Q I Q I. Do you read with me? We have A dot B A B cosine the phase angle between A and B. Do you read with me? So if we have 90 degree, because D and Q different 90 degrees to each other, so dot products will be 0. Okay? Yeah. Yeah. And then here minus blah blah. Okay, minus IDA plus IQA JIQA times I. Okay, continue. Here is AA. Yeah. Here we have D. Here we have D. Right? So we have IDA. So inside we have RA plus JXFD. Okay. Minus IQA. We have RA plus JXFQ. Okay. Yeah. So now give E these S's voltage drop, and this E Q S's voltage drop. Okay. Yeah. Sometimes we analyze the voltage equation into the S's and Q S's. Okay. Just let me know. Why? The question is why? Why? Why we do that? Right? Yeah, we modify. The answer is I don't know. You know, right? Why we need to analyze the voltage equation into DS's and QS's? Because if we go back to the theory of construction, we have rotor, right? For rotor, we have two types of rotors, right? We have cylinder, pole rotors, and non-cylinder. All rotors, right? Right? Cylinder. What does this mean, cylinder like this? right? We have for silent, we have normal sound, you know. So this one, we have the number of holes is equal 404, and for here, less than 4. Okay? So, imagine that this one like D axis, this one like Q axis. Okay? Yeah. In this space. Yeah? So, we have the conclusion. So if we have silent pole rotors, we have XS, XDS. Difference XQS. XQS. Yeah, difference. So for non-silent pole rotors, we have XDS equal to XQS. And equal to XS. Equal to XS. Okay? Yeah. This is the reason why we analyze this equation into two axes and two axes. So if the question give you on the XS, so that means non-silent rotors. Because the axis components reacted equal to Q axis. Component reactants. Otherwise, if we would like to calculate XS, this A d square root of 1. X d is S square plus X is S square. Do you understand? This one also stupid. Why we use non-rejectable battery? You know? Environmental effect. Do you know why? When you get a job, you know why? Only Vietnam, only VGU use this one. Non-rejectable battery. Okay. In Germany, how about in Germany?
There's no microphone.
Yeah. Yeah, because the size of class is limited to the 30, right? 30 students.
Yeah. But in big universities there are microphones.
Yeah.
But they're just plugged in.
Okay. You know, I use microphones because of two reasons. The first one, anybody can hear me. The second one, make you not sleeping because I speak loudly. Okay? Yeah. Yeah. Remember that. Just let you know. Okay, so continue. This one for your reference. You need to read Vietnamese too and read that about some Vietnamese slides. Now, what is this? Let me remember what this is. Okay, I remember. Yeah, so for now we have vacuum. This is vacuum. This is vacuum, right? This is vacuum. And maybe it's vacuum move here. Okay. Vacuum. Yeah. So for liking we have the formula, right? V phase here. I use VT means V phase. That's okay, right here. So we have V phase is EA minus J RA plus XS IA. Okay, the same, right? No, just follow. Okay, follow this. Okay, minus J XF IA minus J XS IA is minus IA RA. Okay, okay. Or we can get AI is V phase. Okay, this is V phase over dot. So that means I write here V phase with 0 degree. Are you agree with me? Yes. Okay. So minus JXS plus, because you move here. Okay. You move this term to the left side. Left side. Yeah. Okay. So SS is constant. For IA, that means magnitude of IA, right? With the phase angle. With the phase angle. You stay here. This is V phase. IA here, so that means you need to follow clockwise direction. Right? Clockwise direction, so this one should be minus. Minus. So you get minus theta. Minus theta. Here they don't use theta, I use phi, that's okay. Because sometimes I am split. So I don't remember theta, I use phi, but the same. You understand? Continue. And here you get plus RA, okay, IA with minus theta. With minus theta. Okay? Here, here. Yeah. Or if here we have AI, and I would like to use XS IA with 0 plus IA with 0. So we have V phase with theta. Do you agree with me? Do you agree with me? So if you stay here and V phase now is reference and we follow clockwise, you get here is minus. So IA here is IA with the minus theta. Now I don't want to stay here because I am free. So I stay here. Okay, so now I choose this one is reference axis. Okay, so IA is in the same direction of reference axis. So IA now becomes 0 degree. And the H line here, so if I would like to meet V phase, I need to follow counterclockwise direction. Okay, so that means it's positive. So move. Because so V phase now becomes magnitude of V phase with the phase angle. Okay? Understand? Good. Yeah. Okay, yes. How about you? So why? Why we do that? Because, you know, because sometimes we don't know. We don't know. Sometimes we don't know magnitudes and phase angle at the same time. Maybe you just know one of them. Or the questions also require us to calculate magnitudes or phase angle. Here we have one equation, but two variables, EA and phase angle. Look, one equation, two variables. How can you get the answers? You fail this course. Okay, so we think the easiest way to modify this one to become one equation, one variable. Do you know the idea? Yes? Okay, good. So now, continue. So now we have EA. EA, continue. Now, we are here. So EA is what? EA is what? EA is what? This is 0. This is 0. So I just say here is RA, right? RA, RA, IA, right? Here is 0. So you just get J's, XS, IA. Now we don't need angle anymore. Because the phase is 0, no imaginary part. We just get it. We just only get. We only get real part. Okay? How about this one? This is theta. So if we apply complex number representation, you can get V phase cosine theta plus J sine theta. Do you repeat with me? So here, and move here, and this one, just move far away a little bit, you get V phase sine theta. The same, right? The same. So now, we have real part, right? Imaginary part. Okay? So now, very angry. Okay, so now we have EA dot E RA IA plus V5 cosine theta. Okay, this is real part. Plus J, we have V phase sine theta plus XS IA. You get this one? You get this one? So you repeat with me? This is imaginary part. So this is the real part of what? This is the real part of EA. Right? This is imaginary part of EA. Okay? So if I would like to calculate the magnitude of EA, that means the square root of what? The square root of this term, right? Here I just say I just say B. That means you get A squared plus B squared. You can get magnitude. After you get magnitude, you come back to here, you can continue to calculate phase angle. You understand? Yeah, this is the way to calculate the variable magnitudes and phase angle. Only one complex voltage equation. Do you understand? Yeah, so here, this is the answer. Okay, so you get what? You get the square root of RA IA plus V phase cosine theta square plus 1 V phase sine theta plus XS IA squared. Remember that we use this formula for lacking. for Lagrange law. Okay? So how about capacity law? So for capacity law, do I have for demonstrations? Explanation here? Oh, yes, yeah. Okay, this is capacity law, and you just modify here plus become minus. Plus become minus. Yes, plus become minus. Okay. Actually, it's this one minus this one. But that's okay because we take this square. Okay. How can you get this one? I have the explanation here. Or you need to demonstrate for yourself because you are really smart. Okay? Do you understand?